Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about trial and improvement. So let's start with a skill I need you super good at for this video. You need to be a real expert on substitution. Pause the video and double check you can do that. And we get the answer 21. Now if you didn't get that answer, make sure you go back to your building blocks. If you did get that and you're very confident with it, you've got the skill you need for this particular video. Now, what is trial and improvement and why would we use it? So I'm going to start by linking to quadratics. So, firstly, I'd like you to pause the video and double check you could solve x squared add 2x is equal to 7. How would you do that? Now, again, you should be coming to trial and improvement if you're good at things like that. I'd look at that and go, power of x squared is a quadratic. To solve a quadratic, I must make one side equal to 0. So I'm going to subtract 7 off both sides and get the following. I'll try as hard as I can to factorize something like that, thinking of two numbers that multiply to negative 7 and add to 2, but I wouldn't be able to because there aren't two whole numbers that do that. So what I would do then is use the quadratic formula, where a, the number in front of x squared is 1, b, the number in front of x is 2, and c, the number at the end is equal to negative 7. And you would get x is negative 1 plus 2 root 2, or x is negative 1 subtract 2 root 2. Now we can do things like that, but what we're going to talk about in this video is functions like this. X cubed add 2x is equal to 7. Now we could subtract 7 off both sides for sure, but we haven't learned how to solve cubic functions at all. Now there are techniques to solve these cubic functions, but they can be super complicated. In fact, if you're interested, look up the cubic formula, the equivalent to the quadratic formula here, the cubic formula. It is extremely complicated. So when we're faced with things like this, we tend to use trial and improvement. And what that is we're going to guess an x, okay, that when we substitute in there tries to get me as close to 7 as possible. And in trial and improvement, I'm going to keep guessing in a systematic way until I get as very close to 7 as I possibly can. So let's try that very question and I'll show you how to do trial and improvement. We're told to find a solution to one decimal place to the equation x cubed add 2x is equal to 7. Now the best way to do these is set up a little table. We're going to have x equals there. This is the thing we're working at here. We're trying to work out x cubed add 2x, and remember we want it to be as close to 7 as possible, and here we're going to just put a little comment to guide us and help us be systematic. Now the first thing we must do, we're trying to find two whole numbers such that x cubed add 2x is bigger than 7 for one of the x's and x cubed add 2x is less than 7 for one of the x's. So two whole numbers, and the thing about these whole numbers as well, we want them to be consecutive. That means one after each other. So let's try a whole number. The obvious one to start with is 1. If I put x is equal to 1 here, I'm working out 1 cubed add 2 multiplied by 1. Now I can do that one in my head, which is equal to 3. The comment for this is it's low. It's lower than 7. So I'm going to try x is equal to 2. Is equal to 12. Now that's too high. Perfect. I found the two consecutive whole numbers where one is low and one is high. That is absolutely what I'm looking for. And now that tells me that the answer that I'm looking for must be between 1 and 2 now. Obviously it can't be bigger than 2 because 2 is already too high. It can't be smaller than 1. 1's already too low. Now sometimes you might have to guess a few numbers to find the two whole ones, but that is your first step and you must do that. You can't just start guessing decimals. You must get two consecutive wholes. So next, obviously I'm going to try exactly halfway between these. X is 1.5. Now's the time to get the calculator out. So calculator comes out and I'm going to type it in my calculator with brackets. Bracket 1.5 cubed add 2 bracket 1.5. It's really important you write it like this because I can then use my calculator quickly in a minute. I'll show you what I mean. When I do that, I get the answer 6.375. And that's too low, but it's just too low. So obviously the next guess I'm going to try, I'm going to just go up in increments of 0.1 always. So I'm going to go up to x is equal to 1.6. and work out on my calculator 1.6 cubed plus 2, 1.6. Now if I've left that on my calculator, I can press back, change that 5 to a 6, and back, and change that 5 there to a 6, saving me a lot of time. And I get, when I do that, 7.296, and that is too high. Now this is perfect, and that is always should be my second step, to find two consecutive, as it were, one decimal place numbers, one too high and one too low. That is always my next step. And my third and final step is to try halfway between the 1dp numbers in 2. Now I must always do this last step. Halfway between 1.5 and 1.6 is equal to 1.55. So I must try that. I always must finish on that. So 1.55 cubed plus 2, 1.55. And I get my calculator out. I can write here 6.82, and that's too low. Now why have I done that? Well, a little picture will inform me right at the end. Always draw this little picture for yourself. So what I found is that 1.5, when I put x is equal to 1.5, my answer was too low. When I put as x is equal to 1.6, my answer was too high. And when I put x was equal to exactly halfway between them, 1.55, x was too low. And this helps me see, I only want to give my answer to 1dp, but it helps me see which one of these is closer. Because if you think about it, if it's low all the way from here to exactly in the middle and high here, there must be an answer where it's exactly equal to, but it must be somewhere this side. Okay, so therefore it is closer to 1.6. And the way it always works is that it's the one that's on its own. Okay, low, low, high, this is going to be your answer to 1dp. So x is equal to 1.6 to 1dp is your answer, which you state at the end. So just to run through the method, find two consecutive whole numbers where one is too high and one is too low, then go halfway between them, then keep moving in one decimal places till you find two consecutive one decimal place numbers where one too high and one too low, and then check halfway in between. Draw this diagram and state your answer. Let's give another one a go. Pause the video and see if you can do that yourself. Right, table time. So why don't we try x is, I don't know, 1. That's as good as effort as any. If I do 1 squared to take away 1 over 1, I get 0, and that's too low. If I try x is equal to 2, I'm going to get 2 squared, take away 1 over 2, and 4 take away a half is equal to 3.5, and again that's too low. So therefore I keep going until I find two consecutives. If I try x is 3, I get 3 squared, take away 1 over 3. 3 squared is 9, take away 1 over 3, that's 8 2/3, and that's high. And there we go, I have found my two consecutive wholes. Now it's time to go halfway in between these, and I'm going to try x is equal to 2.5. It's time for the calculator now. 2.5 squared, take away 1 over 2.5. And when you do that, you get yourself 5.85. And that is too high again. So we're going to go lower, but we're going to only go down in one decimal places. So we're going to try x is 2.4 next. So working out 2.4 squared, take away 1 over 2.4. Calculator out. Press the back button, change that to a 4. Change back. Change that to a 4. And we get ourselves 5.34 high. We're going to keep going down in one decimal places. Don't start jumping. You just never know. Never jump. Just keep going down. Take your time. It doesn't take long to do it if you've got your calculator set up right. 4.85. We're getting close now. So I'm just going to write in 4.85 here, and that's too high. Maybe the next one will be good for us. X is equal to 2.2. Remember, we need to find one too high and one too low. 4.38. It seems like the next one's definitely going to work for us. So x is equal to 2.1. The last one, 3.93. There we go. 3.93 0.93, which is too low. And I found myself my two consecutive decimal numbers where they're between. And remember, I must check halfway between those two, so 2.15. That's my last check, then I can draw my picture and see which one's the right one to one decimal place. And I get 4.16, which is too high. Time to draw my little sketch. So here's my little sketch. Well, I tried 2.1 and I was too low. I tried 2.2 and I was too high. And I tried 2.15 exactly halfway in between and I was too high. It's too high here, so the answer must be closer to this one, the one on its own. So x is equal to 2.1 to 1 dp is our answer. And that's it for this video. Thanks for watching.